Hello, my name is Dallas Jones, and this is my presentation on the current and potential applications of strontium iridium oxide. So first, what is strontium iridium oxide? It is a recently developed material. It was discovered in the 1940s at Stanford University, and it has since been found to be not only highly effective, but also a very stable and active catalyst material. As the name implies, it's made of strontium, iridium, and oxygen. And it's made by taking iridium in powder form as well as strontium oxide in powder form. Some of the current applications of strontium iridium oxide is that it's mainly used in sputtering targets, and these are used in the production of low radiation glass. And we can see low radiation glass in cars and doors, as well as just any other buildings that use this type of glass. And because of this low radiation, this allows for less energy to be consumed, so it's beneficial for energy consumption. Some admirable properties of this material are that when these two metals are combined, they create an alloy that keeps said admirable properties. For strontium, those are that it's malleable, ductile, and a good conductor of electricity. For iridium, it's that it's hard and very corrosion resistant. In fact, it's the most corrosion resistant of all elements on the periodic table. And it also, when these two elements are combined, this discards several undesirable properties, such as strontium being excessively active and hazardous to us, and iridium being very brittle. So it gets rid of that. Some future potential applications include, first, improved data storage. And experiments were conducted by the Paul Scherrer Institute in Switzerland on strontium iridium oxide. And what was found was that the objective of these experiments were that they wanted to find an antiferromagnetic material. So this is a material that produces no overall magnetism to its surroundings. And by analyzing strontium iridium oxide in the form of thin films, they learned that it has the potential to allow for more data on a specific space, more so than other materials. Another future potential application is that of spintronics, which is a newly emerging field of electronics that allows for more capabilities for our current devices. The basic theory behind it is that we manipulate the electrons of certain materials in order to achieve different properties in the materials themselves. So in the experiments mentioned previously by the Paul Scherrer Institute, the U.S. Department of Energy further analyzed the results of their research, and they found that they could acquire a greater understanding of how these electrons in the alloy of strontium iridium oxide can be changed to fit certain desired properties. And so this was a big deal for current understanding as we know it, as well as potential future use. And lastly, for renewable energy sources. It was a group of researchers at Stanford University who found that strontium iridium oxide is remarkably stable and very interactive with its surroundings after they performed certain experiments to affirm if strontium iridium oxide was an effective catalyst. And the results showed that it did indeed perform well. In line with this thought, the American Elements, which is an advanced material manufacturer, also commented that strontium iridium oxide has the required oxygen evolution reaction necessary for renewable energy sources, such as fuel cells and rechargeable batteries. And so it proves very beneficial in these three areas. And finally, what makes these applications feasible? As we've learned in class, we see that we can manipulate the structure of materials to attain certain properties, and this is mainly done through heat treatment of materials. So when strontium and iridium oxide are combined, this allows for strontium iridium oxide to take place or to be formed, and then we can really see just how we can manipulate the materials even further so that we can apply them. And both allow the material to be effective as well as desirable. And this field of studying strontium iridium oxide contributes to further research and future applications, some of which can be seen in as few to 10 to 20 years. Included references. And that concludes my presentation. Thank you very much.